what we're going to do is we're going to continue with this series of problems that we started in the previous video, where we're starting from 6 carbons and we're trying to design a synthesis for these molecules, okay? And when I say 6 carbons, no more than 6 carbons. Okay, so now we did A and B in the previous video. We're going to attempt to do C, D, and E in this video. So let's take a look at C out here. So for C, and this, I think C is a shorter one, so we don't have to probably go to the next page out here. So we'll just go ahead and think retrosynthetically for C. That's a double bond out there. So well, what we want to do is we can think about how could we create a double bond. So retrosynthetically, that double bond could have come from the dehydration of an alcohol. Okay, so we could just put an alcohol out there, okay, like that. And then if we take that one step back from there, and we're like, well, how could we create that alcohol? We could have created that alcohol from an aldehyde, a ketone, right? And then how could we create that ketone from a benzene ring, which is the 6 carbon species out here? We could have done a Friedel-Crafts acylation. All right, so the forward reaction, I'm going to do that in a different color out here. Let's use green. The forward reaction would simply be to go from the benzene to the ketone product. We're just going to use this reagent, okay? And then from the ketone to the alcohol, we'll just reduce that with sodium borohydride, NaBH4, ethanol, step 1. Step 2 is H3O plus. And then in the third step, to get this, we can just dehydrate the OH. You can use any of many different reagents. We'll just use POCl3 with pyridine out here. All right, hope that made sense. Let's take a look at the next one. The next one is very interesting. So you have a tertiary alcohol. Switch back to my colors. You have a tertiary alcohol. And what's crucial out here to understand is 2 of the groups are similar. When that happens, you always want to know that this actually came from a Grignard reagent, Grignard reaction with an ester. Okay, so the key thing to remember, what kind of Grignard are you starting with? So if I draw a little bond out here, if I or what I could do is I could think of this. Well, let's just do it this way. So if I draw a little bond between the O and the H, that bond comes down. So that's the C double bond. That's going to become the C double bond O of the ester. And then these groups are going to leave this way, okay? So if I go backwards from that, I'm going to write the benzene as a pH out here, pH, and then I'm going to put the C double bond O, and then I can put in any group connected to the O of the ester. So I'm just going to keep it simple and put a CH3 out there. And then that's going to react with the Grignard reagent, which is going to be basically this piece with the MgBr. So plus MgBr. Okay. So there's the Grignard and there's the ester. Now, the question though says we cannot start with more than 6 carbons. So therefore the pH is already 6, which means we got to figure out how to bring this onto the pH, okay, or onto the aromatic ring, okay. So what we can do is out here, this one is a little new to you guys. You want to think backwards. This could have come from a carboxylic acid. So if you had this as a carboxylic acid, you could make this using the Fischer esterification, okay? So that's what we'll do to make this, okay? And then how do you make the carboxylic acid? And you just say, well, I could have had the carboxylic acid come from oxidizing toluene with something like KMnO4 to get this. And then we all know how to make toluene. You could do this using just a Friedel-Crafts alkylation for toluene. It's not the cleanest reaction, or you can go cleaner by, instead of toluene, what we can do is just make a CHO, C double bond OH, a formaldehyde, and that would be a very clean reaction because the gadamine coke formulation introduces this group to this. So we'll just use that methodology, okay? So I'm going to go ahead and do the synthesis piece of C on another page so you can kind of see it play out clearly. Okay, so let's go ahead and add that page. Okay, I might have to refer back to what was going on, but I think I probably remember. All right, so synthesis of C. So you start with benzene, you do the gadamine coke formulation. Those are the reagents. End up making benzaldehyde. You oxidize the benzaldehyde with KMnO4. That gives you benzoic acid. Then you do the Fischer esterification. So you using acid as a catalyst, and we had a CH3 out there, so you use methanol. Okay, and then once we have the Fischer esterification, now we have the ester. We're gonna use our Grignard followed by H3O plus. And basically what it does is two of these Grignards attack that to form the tertiary alcohol that we had. As the product. And there you have it. That is C for you. Okay. All right. Let's take a look at. Sorry, was that? I'm sorry. Hold on. Was that C or D? That was D. Oh, my bad. Okay, that's D for you. Okay. Now let's take a look at E. Okay. So since we're doing this on another page, I'm just going to go ahead and rewrite E on another page and do it in a clean fashion. Okay, E. So you have a double bond, and then you have an ethyl group out here, and you're trying to make something that looks like chicken feet. But again, key thing to remember is see how these two groups are similar, which means there was a Grignard involved, and it was involved with an ester. Now, in the past example, we saw that when you take a Grignard and react with an ester, then you end up with a tertiary alcohol. So what we can think of is, if I think one step back, I could change that double bond into an alcohol. So I put an OH. The key is to remember that the OH goes at this position where the branching starts of the two similar groups. Okay, so that's the position of the OH. Okay, because now we know if we have an OH out here, we can dehydrate to form that. Okay, so then the next question is, well, how do we make this compound? Well, from the ester. So let's adopt that same strategy. If we throw that bond down, that bond breaks off, that bond breaks off. So really our ester is, I'm going to rewrite this first. ET, that's two carbons, that's the third. Then you have C double bond O, and we can do OCH3. So that's the ester. And then these two pieces are the Grignard. So it's going to be MgBr. All right, so now we have a strategy. So let's do the synthesis. Okay, so we'll just straight away start with ET. And we take the Grignard. And in step 2, we do H3O plus. And that gives me the OH. and with the 2 chicken feet. All right, then I'm just gonna dehydrate. So out here, concentrated H2SO4 should do the trick. And there you have the product. Oh, I'm sorry, too few carbons out here. And there's the product for E. Okay. All right, let's do the next one. The next one is F. How am I going to make this? Starting with 6 carbons or less. So this one, let's think retrosynthesis out here itself. So whenever you see a double bond out here, you can always think that one of those. So you want to think that it actually came from a ketone and then a corresponding Grignard reagent. That's the strategy, okay? Because that piece will attack here, pushing that up, making an alcohol, and then you can dehydrate the alcohol. Okay, so that's what you want to think about. Okay, so out here, and as you can see, both of these are 6 carbons apiece. So the synthesis actually is very easy out here. You just start with, it's a 1-step synthesis. Well, 2 steps. You start with a ketone, you add this as your Grignard reagent, follow it up with H3O plus, and that is going to give you this. Then you just dehydrate. Again, your concentrated H2SO4 should again do the trick because you have a tertiary alcohol. Boom. And there you have it.